Pressure. Learning objectives. Pressure and its main characteristics. Use of pressure in daily life. Pressure in solids, liquids and gases. Measuring atmospheric pressure. When a force acts on an object, pressure is produced. In other words, pressure is the force acting on a unit area of the object. In everyday life, we use the term pressure such as tire pressure, air pressure, blood pressure, water pressure and so on. So first let us define pressure. What is pressure? Pressure. Pressure is the normal force, i.e. perpendicular, which is acting on unit area. It is represented by P. Pressure. P equals normal force upon area on which force acts equals F upon A. The SI unit of pressure is N/m², a scalar quantity known as a Pascal and written as Pa. We know that when we pull a spring, or press our hands against a wall or stand on the ground, then we are applying a force. A push or a pull means a force. Whereas, force is important, the more important is the area over which it acts. This leads us to define a quantity called pressure. Thus, it is the force divided by the area on which it acts, i.e. the force, F, per unit area, A, at any point determines the pressure at that point. Activity 12.1. Take a rectangular block, weighing 100 N. The area of the block when placed on ground from its broader side is 0.1 square meters, whereas it is 0.01 square meters when placed on the ground from its narrow side. Let us see the pressure exerted by this block on the ground. We saw that the pressure did not take only the weight of the block into account but more importantly, the area which came under that pressure. Pressure equals 10,000 Pascal, Pa. Main characteristics of pressure. The above experiment proves that 1. Pressure is a scalar quantity, i.e. has magnitude but no direction. 2. The area on which the pressure is exerted is more important. 3. The more the area, the lesser the pressure. 4. The lesser the area, the more the pressure. 5. Pressure at all points at equal depth is equal. Example 1. A block weighing 1500 N rests on an area of 5 square meters. Calculate the pressure exerted by the block on the surface which supports it. Solution. We know that P equals Fa. Here, F equals 1500 N and A equals 5 square meters. What we don't know is the P. Thus, applying the formula we have P equals F upon A, or P 1500 N upon 5 meters into 2 equals 1500 upon 5 equals 300 Pa or Nm-2. Example 2. A cubical block of mass 2 kg with each side of 2 cm is lying on the ground. Calculate the pressure exerted by the block on the ground. Take G equals 9.8 milliseconds minus 2. Solution. The mass of the block, M equals 2 kg. Weight, F, of the block, mg equals 2 kg times 9.8 cm minus 2 equals 19.6 N. Side of the cube, A, equals 2 cm equals 2 upon 100. M equals 0.02 meters. Area of the lower surface of the cube A equals a minus 2 equals 0.02 multiply 0.02 equals 4 multiply 10 minus 4 m into 2. Using P equals F upon A equals P equals 19.6 N upon 4 multiply 10 minus 4 M into 2 equals 4.9 multiply 10 into 4 Nm minus 2 equals 49,000 Pa. A cubical block. Use of pressure in daily life. The following are the uses of pressure in our daily life. The railway tracks are laid on large-size sleepers so that the thrust, force, due to weight of train is spread over large area to reduce the pressure on the railway line. It is comfortable to carry a load on shoulders because the shoulders provide larger area, thus reducing the pressure on the body. Tractors have large tires so that they present large area to reduce the pressure due to the weight of the tractor on the soft soil. Camel is much heavier than man, still camel walks more swiftly in sand than man because the wide feet of camel present large area, thus reducing the pressure, and so the camel does not sink in the sand. A sharp knife is more effective in cutting the objects than a blunt knife because blunt knife has thick edge which puts the force of our hand to a larger area reducing the pressure, whereas sharp edge presents less area for the pressure to develop and cut the object effectively. A needle has a pointed sharp tip and a blunt large head. The head presents a large area putting less pressure on the finger or thumb, whereas the same needle presents very less area at its sharp tip to develop more pressure so that the needle pierces the object. Tanks, bulldozers, and other heavy mechanical equipment are fitted with the caterpillar tracks which consist of large flat surfaces punctured with short spikes. If the equipment was supported by the spikes only, the pressure would be enormous due to small area of contact. And that would make the equipment to sink only a little way into the supporting surface. The players in a football or cricket game wear the shoes which have spikes on their soles. These spikes provide less area of contact, exerting more of the body weight on the ground so that the player does not fall and remains firm even while running. Spacecraft which landed on Moon and other planets had all been fitted with large area pads on their feet to prevent them sinking too far into the unknown surfaces. Sci facts. It is important to realize that the pressure at a point in the liquid is dependent only on the vertical depth of the point. So, more the depth, more the pressure of the liquid. Stress and strain. The pressure exerted on a surface is sometimes known as a stress and it results in strain. If the supporting surface is not strong enough to withstand this strain, it may bend or break. Example: a man wishes to cross a water body through a plank as the bridge. The wooden plank is thin and the man knows that the plank cannot bear his weight and may break, drowning him into the water. What he does is that he lays flat on the plank and moves slowly along its surface. He reaches safely to the other side. However, the plank is slightly bent in the center. How does it happen? In case he would have stopped over the plank, his feet would have covered small area, exerting more pressure of his body on the plank. Seismic waves. How do earthquakes occur? There are two broad causes of occurrence of earthquakes. 1. Naturally occurring earthquakes. 2. Induced earthquakes. Naturally occurring earthquakes. The earthquakes occur naturally by any one of the following reasons. Tectonic. According to the theory of plate tectonics, the Earth's crust is formed by a number of large plates that move very slowly in various directions on the Earth's surface. Most earthquakes occur near a boundary between two plates. As one plate pushes past or over another plate, great stresses build up in the rock along the edges of the plates because friction prevents them from sliding past each other. Eventually, the stress becomes great enough to rupture the rock. The edges of the plates slip a short distance in opposite directions, causing an earthquake. The greater the stress that have built up, the greater the resulting earthquake. Tectonic. Oceanic crust. Trench. Lithosphere. Asthenosphere. Volcanic arc. Continental crust. Lithosphere. Volcanic. When a volcano explodes, it is likely that the associated earthquake effects will be confined to an area 10 to 20 miles around its base, whereas a tectonic earthquake may be felt around the globe. The volcanoes which are most likely to explode violently are those which produce acidic lava. Acidic lava cools and sets very quickly upon contact with the air. This tends to choke the volcanic vent and block the further escape of pressure. The only way in which such a blockage can be removed by the buildup of pressure to the point at which the blockage is literally exploded out of the way. In reality, the weakest part of the volcano will be the part which gives way. When extraordinary levels of pressure develop, the resultant earthquake is of considerable magnitude. When Krakatoa, Indonesia, exploded in 1883, the explosion was heard over 5,000 kilometers away in Australia. The shock waves produced a series of tsunamis of over 36 meters high. These swept over the coastal areas of Java and Sumatra, killing over 36,000 people. Volcanic. Folding and faulting. A fracture in the rock with an observable displacement over a period of time is known as fault. These faults may cause earthquake when there is movement of earth along a line of fracture, i.e. fault. These faults can be found in rocks of all ages, but they usually cause earthquake when they are located in the active area of plate motion, i.e. in an area where a plate moves against another. Example of this kind of earthquake is the earthquake of 1975 in Guatemala, which resulted from movement along the Montague Fault, which lies between the American and the Caribbean plates. Fault line. Induced earthquakes, also termed as anthropogenic earthquakes, are caused by the activities of man, such as extraction of minerals and fossil fuels from the crust of earth, reserve-induced activities, massive explosions, collapse of large buildings and construction of water masses behind the dams. However, these earthquakes are not strictly earthquakes, as they show a different seismograph than naturally occurring earthquakes. A few earthquakes have been associated are not strictly earthquakes, as they show a different seismograph than naturally occurring earthquakes. A few earthquakes have been associated with the buildup of large masses of water behind dams, such as Kariba Dam in Zambia, Africa. Such earthquakes occur because the strength of the Earth's crust can be modified by fluid pressure. Removal of natural gas from subsurface deposits is also believed to be a cause of earthquakes. The world's largest reservoir-induced earthquake occurred on December 10, 1967 in Koyana region of Maharashtra in India. The detonation of powerful explosives such as nuclear explosions can cause low-magnitude ground shaking. Induced earthquake. Damages caused by earthquakes. Large earthquakes cause serious destruction and massive loss of life through a variety of agents of damage. These are fault rupture, vibratory ground motion, shaking, inundation, tsunami and dam failure, ground failure, landslides, fire of hazardous release material, for example, petrol and gas leaks. In a particular earthquake, any of these agents of damage can dominate. Historically, each has caused major damage and huge loss of life. Shaking is the dominant and most widespread causes of damage. Shocks. Most large earthquakes are accompanied by other smaller ones that can occur either before or after the main shock. These are called foreshocks and aftershocks, respectively. While almost all earthquakes have aftershocks, foreshocks occur in only about 10% of earthquakes. Earthquakes that occur below sea level and home large vertical displacements can give rise to tsunamis, either as a direct result of the deformation of the seabed due to the earthquake or as a result of submarine landslides directly or indirectly triggered by the quake. 1. Magnitude. 2. Intensity. 3. Frequency. Measurement of earthquakes. Since seismologists cannot directly observe ruptures in the Earth's interior, they rely on geodetic measurements and numerical experiments to analyze seismic waves and accurately assess the severity of earthquakes. The severity of an earthquake can be measured in terms of magnitude. The magnitude of most earthquakes is measured on the Richter scale, invented by Charles F. Richter in 1934, and then modified by Richter and his colleague Benno Gutenberg in 1965. The Richter magnitudes are based on a logarithmic scale, base 10, which means that for each whole number you go up on the Richter scale, the amplitude of the ground motion recorded by a seismograph goes up 10 times. This scale can be related to the energy released at the center of the earthquake. Using this scale, a magnitude 5 earthquake would result in 10 times the level of ground shaking as a magnitude 4 earthquake. This scale does not have any fixed minimum or maximum. Earthquakes of magnitude 2 are the smallest that can normally be felt by the humans. Intensity. The intensity of a particular earthquake is measured on an intensity scale. It gives the capacity of destruction of an earthquake and is measured in relation to the effects of earthquake on life and property. While the non-specialized media will often refer to the scale, the magnitudes reported nowadays are actually on the moment magnitude scale. The older Richter scale is not adapted for larger earthquakes. Frequency of occurrence. Small earthquakes occur every day all around the world and often many times a day in places like California and Alaska in USA, Indonesia, Azores in Portugal and Japan. Large earthquakes occur less frequently. The number of earthquake reporting stations increased from about 350 in 1931 to about 4,000 today. As a result, many more earthquakes are reported now than in the past, i.e. 35 per day worldwide. This does not necessarily mean that the number of earthquakes has increased. It has been estimated that since 1900 there have been an average of 18 earthquakes of magnitude 7.0 to 7.9 per year. Nepal earthquake 2015-16. Effects and impacts of earthquakes. Some of the effects and impacts of earthquakes are discussed below. Direct shaking hazards. Most earthquake-related deaths are caused by the collapse of structures. This type of hazard took a toll of more than 1 lakh people in Italy in 1909. Almost half of the people living in the region of Messina were killed due to easily collapsible structures. The direct shaking effects are not the only hazards associated with earthquakes. Other effects such as landslides, liquefaction and tsunamis have also played important part in destruction produced by earthquakes. Shaking hazard. Liquefaction. Buildings can even sink into the ground if soil liquefaction occurs. Liquefaction is the mixing of sand or soil and groundwater during the shaking of a moderate or strong earthquake. When the water and soil are mixed, the ground becomes very soft and acts similar to quicksand. If liquefaction occurs under a building, it may start to lean, tip over or sink several feet. The ground firms up again after the earthquake has passed and the water has settled back down to its usual place deeper in the ground. Liquefaction is a hazard in areas that have groundwater near the surface and sandy soil. Buildings can also be damaged by strong surface waves making the ground move. Any buildings in the path of these surface waves can lean or tip over from all the movement. The ground shaking may also cause landslides, mudslides, and avalanches on steeper hills or mountains, all of which can damage buildings and hurt people. Tsunamis. Tsunamis and seisures can also cause a great damage. A tsunami is a big tidal wave, but it has nothing to do with the tides on the ocean. It is a huge wave caused by an earthquake under the ocean. Tsunamis can be tens of feet high when they hit the shore and can do enormous damage to the coastline. Japan tsunami. Fire. Earthquakes are often followed by fires. These fires can be started by broken gas lines and power lines. or tipped over wood or coal stoves. They can be a serious problem, especially if the water lines that feed the fire hydrants are broken, too. For example, after the Great San Francisco earthquake in 1906, the city burned for 3 days. Most of the city was destroyed and 250,000 people were left homeless. Fire after earthquake. Flooding. The third main hazard is flooding. An earthquake can rupture or break dams along a river. The water from the river or the reservoir would then flood the area, damaging buildings and maybe sweeping away or drowning people. Flood after earthquake. What to do during an earthquake? If indoors, drop to the ground. Take cover by getting under a sturdy table or other piece of furniture. If there isn't a table or desk near you, cover your face and head with your arms and crouch in an inside corner of the building. Stay away from glass, windows, outside doors and walls, and anything that could fall, such as lighting fixtures or furniture. Use a doorway for shelter only if it is in close proximity to you and if you know it is a strongly supported, load-bearing doorway. Stay inside until shaking stops and it is safe to go outside. Research has shown that most injuries occur when people inside buildings attempt to move to a different location inside the building or try to leave. Do not use the elevators. If outdoors, stay there. Move away from buildings, street lights, and utility wires. Once in the open, stay there until the shaking stops. The greatest danger exists directly outside buildings, at exits, and alongside exterior walls. Most earthquake-related casualties result from collapsing walls, flying glass, and falling objects. If in a moving vehicle, stop as quickly as safety permits and stay in the vehicle. Avoid stopping near or under buildings, trees, overpasses, and utility wires. Proceed cautiously once the earthquake has stopped. Avoid roads, bridges, or ramps that might have been damaged by the earthquake. If trapped under debris, do not light a match. Do not move about or kick up dust. Cover your mouth with a handkerchief or clothing. Tap on a pipe or wall so rescuers can locate you. Use a whistle if one is available. Shout only as a last resort. Shouting can cause you to inhale dangerous amounts of dust. Keywords. Seismology. Study of earthquakes. Seismologist. The scientist of the earthquakes. Seismograph. The instrument that records the earthquake waves. P waves. Primary waves of an earthquake. S waves. Secondary waves of earthquake. L waves. Long waves of earthquake. Foreshocks. Shocks felt before earthquake. Aftershocks. Shocks felt after earthquake. Richter scale. The instrument for measuring magnitude of earthquake. Magnitude. Energy released at the center of earthquake. Intensity. Destructions of life and property caused by earthquake. Summary. Earthquake is a sudden, temporary motion or a series of motions which originate in a limited region and then spread out to other regions. Most of the earthquakes are caused from within the earth. Earth is divided into layers like core, mantle and crust. The earthquake zone lies between the crust and mantle. There are 3 types of earthquake waves which are P waves, S waves and L wave. Earthquakes may occur naturally or they may be induced or man-made. Tectonic, volcanic and faulting are the natural phenomena of earthquake. Induced earthquakes are caused by the activities of man. Extraction of minerals, dam construction, atomic and other explosions cause the induced earthquakes. Earthquakes cause fault ruptures, shaking, inundation, ground failure, fire or release of hazardous gases, etc. Shocks are the after effects of earthquakes which also cause damage. Earthquakes are measured for magnitude on Richter scale and for intensity on intensity scale. Major earthquakes are nowadays measured by movement magnitude scale. There are about 4,000 earthquake reporting stations today. Strengthening the structures will prevent the damages done by earthquakes.